So I'm cruising in my Prius at 10 meters per second when I gun the gas and accelerate to a whopping 5 meters per second squared for 3 seconds. What is my final velocity and how far do I travel during those 3 seconds? Let's do it. This is a very straightforward problem, so you can just use the definition of acceleration, v equals v naught plus at. Plug in and solve to get 25 meters per second. How far in 3 seconds sounds like the distance formula, so let's use that and set x naught, our starting point, equal to 0. Plug in our numbers and solve to get 322.5 meters. This is about as straightforward a kinematics problem as you're ever going to find. Okay, this problem is here to prove a point. We have ourselves a little car that can drive according to a particular displacement equation as shown. Now, if we evaluate the velocity of that car, we can do so under shorter and shorter time intervals and get closer and closer to what we call the instantaneous velocity rather than the average velocity. Here we go. To find the average velocity between 5 and 6 seconds, we have to evaluate the function at 5 and 6 seconds. We get 70 meters and 101 meters respectively. That means the car has a change in position of 31 meters and did so in 1 second. Velocity is change in distance over change in time, so we get 31 meters per second. If you repeat that exact process between 5 and 5.1 second, you get 28.3 meters per second, a little bit slower. Do it again between 5 and 5.01 second, and we end up with 28.03 meters per second, much closer to the previous answer. One more time with an even smaller time interval gets us 28.003 meters per second. What we've done here is gotten closer and closer to a time interval of 0. Now it's impossible using algebra to get a time interval of 0. For that you need calculus. So this is again calculus light. By using a smaller and smaller time interval, we get farther from a broad average velocity and closer to the instantaneous velocity at 5 seconds, which by the way happens to be 28 meters per second exactly. For this next problem, Alicia and Bryce are standing at the top of a 50-meter cliff. Alicia throws a rock straight up at 20 meters per second, and sometime afterward Bryce drops a rock so that they hit the ground below at the same time. How long does Bryce have to wait to drop his rock? This looks like it could be kind of confusing, but it's really more straightforward than it first appears. For both rocks, you know not only their initial and final displacement, you know their initial velocities, and you know the acceleration is the acceleration due to gravity, g, minus 9.81 meters per second squared. This makes the distance formula the obvious choice of an equation to start with. If we call the ground 0 meters and plug in our numbers, we get a quadratic equation for Alicia's time, and that solves as minus 1.749 seconds and 5.827 seconds. We reject the negative answer as physically impossible. Moving on to Bryce, his rock has no initial velocity, so we can plug in and solve. We get plus or minus 3.19 seconds, and again reject the negative answer as physically unreasonable. How long Bryce has to wait to drop his rock is now simply a matter of subtraction. You get 2.63 seconds. So Maya blows past a police officer in the school zone out front at 30 meters per second, that's 67 miles an hour. If it takes the police officer 3 seconds to put down his coffee, put his car in gear and hit the gas, then he accelerates at 15 meters per second squared. I'm going to ask you a bunch of questions related to this, and this is a quintessential AP Physics problem because it requires that you not only use equations, you have to create some. This is a new skill that you can only get better at with practice. The first question is to make a velocity versus time graph of each type of motion. Maya's is pretty easy because she's staying at a constant velocity. Meanwhile, the cop has a time delay and then increases his velocity with an acceleration of 15 meters per second squared. Part B asks us to derive an equation that would allow us to determine how long it takes the policeman to catch her. To derive an equation means we're going to make a new equation from other more basic equations. We're going to need the policeman's time, and our final answer can't include anything that wasn't either given in the problem or is some kind of physical constant like the acceleration due to gravity. I'm going to show you two distinct and different ways to do this. Let's go. The first way is algebraic, and probably the hardest part is answering the question, what does it mean mathematically for the policeman to have caught Maya? Pause the video for a moment and see if you can come up with the answer on your own. It means they've both traveled the same distance. So set the distance formula for each of them equal to each other. And realize the police officer has no initial velocity, they both have initial displacements of 0, and Maya has no acceleration. Rewrite what's left, and realize that the cop's time is Maya's time plus the wait time. Substitute that in, and you get an equation that has only given quantities and what we're looking for. This is the answer. Let's find that exact same answer using the graph instead of the kinematics equations. The area under a velocity versus time graph equals displacement, so if their areas are equal, then they're in the same place. The policeman has caught Maya. Maya's area is base height, and the cop's is 1/2 base height. For Maya, that's time times velocity, while for the cop, his base is time minus the wait time, and his height is his final velocity minus his initial velocity, which happens to be 0. The cop's velocity is his acceleration times his travel time, which we can combine to get the exact same equation we got using the kinematics equations. Two different ways to get the same answer. Now that we have this equation, it ceases to be a physics problem and has become an algebra problem. We can square the binomial, plug in our numbers, rearrange and factor to get time of 1 second and 9 seconds. 1 second is of course preposterous. He can't have caught her before he started moving. We can use v equals v0 plus at to find that the policeman was going 90 meters per second when he caught up with her, because his time is 3 seconds less than her time of 9 seconds. We can then plug in all the information we have into the policeman's distance formula to find that he went 270 meters. Or we can plug into Maya's distance formula and find that she went 270 meters. And if you think about it, these numbers have to agree. That's how we solved the problem in the first place.